Have you ever come across sleek custom UIs for rigs and wondered how to create them yourself? But your thoughts seemed as clear as the weather during a snowstorm? Lucky for you, I'm going to clear it up and show you how to make one. Just like the UI for the Thomas Rig Edit Remastered or the Legacy version, I will show you the basics, but I will not make a complete UI in this tutorial. Use the timestamps below to skip through the video. Creating a custom UI consists of two individual steps. First, editing the rig. You need to add a string property to the rig holding a unique ID. With this, we can code it so that the custom UI only shows when the correct rig is selected. Second, create the script and make all the magic happen. We are now in Blender with the rig opened. For this tutorial, I will use the Digital Dan simple rig to show you how to make a custom UI. We open the user preferences, go to interface on the left side and activate the developer extras, the user and the Python tooltips. In the add-ons tab of the user preferences, we also activate the developer icon viewer add-on. After this, we just save the user preferences and go back to the viewport. After these initial steps, we start by creating the rig ID. Select the armature, go to the custom properties and add a new property with the type string and the name rig ID. The property name must be rig_ID. The value of this property should be set to a unique ID for your rig. Since I have the Digital Dan rig here, I will use Digital Dan 5.3. Then we go to the scripting tab and create a new text block. By importing the BPY package, we can access every data inside of Blender. It acts as a bridge between our written code and Blender itself. We can retrieve data with it, and it provides functions to change different kinds of data. To create a custom UI, we define a class, which inherits a panel type. In this case, the class name is Digital Dan Rig Panel. But for you, it might be a different name. The name of this class isn't really that much important, but you should somehow use a name that represents this panel. Adding BL infos is necessary to tell Blender what to do with this panel. BL label will set the name of this panel. So in my case, I just called it something like Digital Dan. The ID name defines the ID for this panel. We first add object_pt. It is a coding habit inside of Blender, so you don't really need to care about it that much. And then your unique ID for this panel. I use Digital Dan Rig, but you need to use another identifier. The space type is in which space the UI should show. We want it to be in the view 3D, so we will use that. The region type specifies even further where this panel should be located inside the viewport. We want it to be in the side panel, so we use UI here. The last variable of the BL info we have to set is the category. It is the label of the new panel we create here in the sidebar. The UI panel itself will be put inside of this category. To display anything in the panel, we have to use the draw method with the parameters self and context. Self is the class object itself we are passing, and the context is just the current context we have in Blender. Now we can begin to script the UI components. The first component we use is the layout. This is given by Blender as an attribute of this class already. So we set the variable layout equals self.layout to access this attribute of the class. We will continue here in a moment. Before, we are correctly telling Blender that we want this panel to be shown, so we need to register it. So we write a register function. In this, we call the register class function that registers our class containing our panel. The same for the unregistering part. Because we are only defining these functions, Blender will not execute them. For this, we need to tell Blender that we want to execute the register function, which executes the script and registers the panel. Therefore, we will write following. If __name__ is equals to __main__, then we want to call the register function. If we now execute the script, the panel category and label will pop up. So far it had been empty since we haven't added any stuff into it. We have different UI components we can use. These include column, box, row and split. There are even more, but I will not talk about them in this tutorial. The column does what it says. It will show the items inside this column beneath one another with a small margin. The box has a darker background for all the UI items that are inside of it. The row puts all the items appointed to it in one line. The split does the same thing, but we can define a factor value at what point the component splits the parts. For example, the left and right side. We can also nest these components. We have got the main layout. All the white boxes represent items inside the components. We use a box and will create a darker backdrop behind the items that are in it. By nesting a row inside this box, we can have two items inside one line, also in the box. Adding a column to both sides of the column will give us the following. And if we nest a box inside the right column only, we will get an even darker backdrop, but only for the right side. We don't need to nest. We can also put components next to each other. I add another item beneath the first box, which I nest inside a box. It will be inside a box beneath the other one. Since we only want to show the custom UI when the rig is selected, we will do that in a moment, we need to get a grip on the rig. We use the active object attribute of our context for that. So we declare the variable rig and assign it to the active object. To show information in the panel, I create a label on the layout. So I call the label method on the layout object, and we use the input parameter text and set it to what we want to be displayed. I already told you that we can nest UI components, so I want the label to be displayed inside a box. So I add the method call box to create the box component, and I will directly call the label method on it. If we do it like this, we can only access this box component once, because we don't have a reference to this box component stored in a variable. Therefore, there can only be one item in it. As you can see, it is in the box now. We add the unlocked icon to this label by using the icon parameter, passing this icon value. Just a little addition here, to see all possible icons in Blender has to offer and from which you choose, I will open the side panel. We go to the Dev category and open the icon viewer. If you want to use one from them, click on it and the name of this icon will be copied to your clipboard. For the icon parameter I use unlocked. This will display an unlocked icon in the custom UI for this label. To have the icon on the right side in this row, I have to add another item in this row which only represents the icon. So I just did what you can see here. But how do I show properties of this rig in the custom UI? We have got different bones full of properties, and in the following I will teach you how to access them and put them inside your panel. The properties I'm currently showing you are Boolean properties. If you have an integer property with the slider, you can change that by going to the bone properties, click on the little gear and change the property type from int to Boolean. But do this if the integers are limited to two values only. For example 0 and 1, which also represents a Boolean. But how do we actually access this property in the script? I want to show the Alex arms properties of the gen props bone. So the first step would be to get the bone. Therefore, we declare a new variable, gen props, and assign the bone to it by accessing the bones of the rig like this. Then we look up the bone by putting the bone name in the brackets. So I create a new column instance nested in the layout. Every time I assign, let's say an item, to the column, it will be displayed in it. Therefore, it has a smaller margin between the items than if I use the normal layout. I will now call the prop method on this column. This will create a new item in this column. I also pass the object from which I want to show a property and the name of the property. In this case, I need to pass the gen props and the Alex arm as a property. We need to write it with the single quotation marks, the square brackets and the double quotation marks. Otherwise, the property will not be accessed correctly and it won't work. You can see the property is in the custom UI and it is displayed as a checkbox. I, however, like it to be a big toggleable button. For this, I need to pass another argument to the prop method. We set toggle equals true. We also have other properties we want to show, so I just put them in real quick. Now you can even see how small the margin between the elements really is. For better aesthetics, I want to put the column inside of a box. So just define a box and nest the column inside it. We need to put the column inside the box and not the other way around. You can try that yourself and see what happens if you don't know already. We can even merge the items of the column together if we set the align argument to true. But since I don't like the look of this for this use case specifically, I will not remove the margin between the items completely. If you want to access a different property of a different bone, we must again store this bone data so that we can access it better when displaying the property. In this case, I want to show a property which is on the right arm bone, so I assign the new bone to the right arm variable. I want to create a new box in the layout and then show the IKFK toggle inside this new box. Since this property is a slider, we can even use the slider argument and set it to true, so that the property has a blue bar which shows the current value better. Now we will organize the UI. We will use an enum property to have control over which sections we want to be drawn in the custom UI. So we define the enum property on the object with the name selector. Items is a list of options, and we can select one item which should be active. Every item in this list is a list as well, which contains 3 different values inside. The first is the identifier, the second is the name, and the third is the description. The description is optional. But if you don't want a description, we need to use an empty string for that. I told you already that the UI should only be drawn if the correct rig is selected. Therefore, we use the class method pull, which controls the visibility of the panel. We try to return the comparison of the rig ID property to the rig ID we set in the beginning. If there is any error or Blender can't access the rig ID, it should return false, not to show the UI. As you can see, if I don't select the armature, the UI will not pop up. But now back to the categories. We can access the currently selected item name of the enum property by assigning the value of the selected property to selector. This makes it easier for us to use and access the value. Now we can code when which part of the UI should be drawn. For this, we filter the first identifier of the enum. If this is selected, the following code is executed. The if statement checks if the comparison we do is true and then go into the next intended code block. We do the same for the second category, but instead of the if, we use an elif here, since if the first is true, we don't have to need to check the second, because it must be false. Especially because the enum can only hold one active item. Don't forget to show the selected property in the UI panel as well. For this, we call the prop function on the layout and pass the rig and the property name as the arguments. The property is directly stored in the object, so we don't need to use a bone or whatever for that. Since we created the property in code, we don't need to use the brackets for the property name, like we had to do with the bone properties. So let's see if it works. And it does. It is a drop-down menu and we can select which UI block gets displayed. But we can also use the expand preview of the enum instead of the drop-down menu. For this, I will pass the expand equals true argument to the prop method like this. We are not only restricted to showing bone properties, but can also show any kind of property which we can find in the Blender UI. So let's add a control for the bone collection and layers and their visibility. We get a list of the available bone layers by accessing the data of the object and then getting the collections all attribute. This is a list full of all bone layers of this armature. Since I also want to have the layers control in the same box as the IK toggle, I will have to rewrite it a little bit so that we can access the same box instance more than just once. For this, I use a column inside the box and I will put every UI item in this column. I now hover over the visibility property of the bone layer. As you can see, Blender now shows us the Python tooltip and a hint how to access the data of it. With this information, we can see how to use it and which property attribute we need to display. It's the isVisible attribute. I will show a new property in this column. with the accessed layers and the name of the desired layer in brackets behind it as the first argument, and the is visible as the second to define which attribute we want to show. In this case, we display the bone layer named layer 1. Since I want to have the name of the bone layer in the custom UI, I will overwrite the label of the column item. I also want to have the big button. For that, I will overwrite the toggle value. You might also want to show a setting of a material, for example, the color of the eyes. But it doesn't matter which material or which setting you want to have. We also need to somehow be able to access it relatively. We can't access it by name, therefore we create a material object which has all the materials on it we want to have access to. To be able to read it properly from the script, we need to be able to reference it. The easiest way would be to parent the material object to the armature and then make it the first child of the armature. So we rename it to something like 00_mats, because Blender sorts the children of the armature in alphabetically order in the outline. It will be the first child therefore. If this is not the case, make sure that you change it until it is the first. Then I close the outliner because I don't need it anymore. Instead, I will open a new shader tab here. To show you the procedure how to display a node input in the UI, I will do that with the eye material. As you can see, we have the right eye node group which controls the color. We head to the script and add a new category for the material. Then we create a new variable which points towards the material object. We do this by getting all the children of the rig and taking the first element of this list. To also have the darker background for the options we're going to add here, we will make a new box UI component. We add a label and the material icon so that we know which material we want to draw. After this, I create a row so that the color options will all be in one line. To specify the source of the color input, we need to declare it by accessing the correct node of the corresponding material. Therefore, we set the value of the new right eye variable. Take the material object, get all the material slots, and use the slot which is our right eye material. In this case, it is the second slot, so we use 1. Then we specify that we want to have the material assigned to this slot, the node tree with all its nodes, and get the node group by its name, not the label. We use the inputs for this node, so we get a list of all the inputs. With this, we can easily access the inputs of the node group later. Now we can use this to display the first color input of the node group. Create a new prop method call on our row and pass the first element of the right eye list, which is the position 0 in the list, and the default value is the property value we want to show. After executing the script again, the color input will appear in our custom UI. To remove the default label, we can just set the text parameter to an empty string. I will add the second color input. As you can see, there is a margin between both of the row items. To remove this, we can add the align argument and set it to true when creating this row. But if I disable the face of the rig, the material options still show up. In my opinion, it is a bit unnecessary to be able to change the eye color since the eyes aren't even showing. So we will change the script a tiny bit to deactivate the color properties in the UI if the face is deactivated. For this, we need to set the enabled attribute of the row to the value of the face toggle property like this. Now the color option is grayed out. If the face is activated, we can still change the color. Another approach would be to only show the properties if the face is activated. For this, we add a new if statement in front of the lines in which we display the properties. This will check if the face is activated, and if so, it will go to the intended code block and execute it. Otherwise, it will skip it. Just one annotation, I left the equals true out because we check a boolean property, and this is already either false or true. To negate it, so for example, you want to show it when the property is false, we have to put a not in the if statement right in front of the property while we check. We can then also delete the row enable change because it will always be true if the row itself is shown. The next thing I want to show is how we can change an image texture in the custom UI. This is a little bit more complex because we must consider that if the image is packed, we cannot change the source. We need an operator to do this for us and show the current packed state for us. I want to change the skin, so we go to the material which contains the skin texture in an image texture node. I will begin by creating the image pack operator. We define it like the panel with a class, but this time we inherit the operator type from BPY. This again needs an ID name, which needs to be unique again, and it should also tell us what the operator does. I call it a digitaldanrig.imageReload. It also needs a BL label, but I want no label shown later in the UI, so I will set it to an empty string. Now comes the tricky part. We create a string property inside this operator, which should retrieve the image name later on, which we can then use to pack the image. Make sure to use a colon and not an equal sign. Images have a unique name inside Blender, so we can actually use the name for that. We will pass it when showing the operator in the custom UI, so that we could potentially reuse it later on if we want to do the same for another image texture. Operators execute actions. We need to tell it what it should do, so we define an execute method with the arguments and self and context. We create a variable that stores the image, so we find the image inside the Blender data by using the ID name, which is the name of the image texture. To access the ID name, we have to put self in front, because we want to access the variable of the operator instance. Then we check if the image is packed or not, because we will need this in the UI later as well. I will write it as a function that returns the packed state of the image. Let's call the function isPacked and have the image name as the argument. I will not explain this code snippet in detail now, but it returns if the image texture is packed or not. Back to the operator, we will write an if statement and call the isPacked function. We also pass the image into it. If it's true, we know that the image is packed and we want the operator to unpack it. If the image file is saved, we just want it to be unpacked. Otherwise, we want it to be unpacked, but with the argument that it should use the original files. This is not completely needed, so we can instead check if the image file is saved by just saying unpack it, no matter if it's saved or not. However, we still need to write what it should do if it is not packed. So we write an else clause for the first if and call the pack method on the image. After that, the operator is finished and we return the finished string in curly brackets. We don't only want to be able to pack and unpack the image in our panel, we also want the possibility to reload the image if needed. So we write another operator which will do that for us. It is the same procedure, creating a new operator class and setting an BL ID name, the label and the ID name, which will tell us which image it should reload. In the execution method, we get the image data and just call the reload method on it. Then we also return finished. After defining all the operators, we also need to register and unregister them, just like the UI panel before. I copy-paste the register and unregister function calls and use the new class names as the arguments. For the unregistering, we need to unregister them in reverse order. When that's done, we can finally head back to the panel class and write a little bit more code to display the new operators and the image changer. I just make a little space here and then create a label for the skin changer in the box. Create a new row instance on the box, which we will store in the variable named left. We set the align argument to true. To show an operator, we need to call the operator function on the UI component. We pass the operator ID name as the argument. Because we have already defined the label to be an empty string, I don't need to set the text here to an empty string. But we want the operator to have an icon. I will arrange that a little bit prettier so that it will not look like a complete mess. The icon should depend on if the image is packed or not. To do this, we will use a short if statement here. We set it to the package icon if the image is packed, otherwise it should be the ugly package. A very important step is to now specify the ID name value for this operator. With this, the operator will know which image it should pack, so we just assign the image name to it. Now, we also want to show the actual file path of this image. We create a new row instance on this row and name it main. We will also align it. As I showed you earlier, we will now use the enabled attribute for this one. It should be enabled if the image is not packed, so we assign the negated value of the return of the isPacked function to it. Then we show the file path like following. The last step would be to display the reload operator. I think you will understand the code that I write for this one by yourself.
But one day you'll figure this out. And when you do, you will change the world.
I forgot to define what the image is, so I need to also create the new image variable and assign the image to it. We access it by retrieving the image texture node and the image attribute of it, like this. If we now execute the code, we have the image controls here to change the texture. We can pack, unpack, reload and change the image. Now, when you are finished writing your script, you also want to convert it into an add-on. You don't want to always have to manually executing your script when you want to use the custom UI. Just hopping into Blender and start making renders with this rig needs additional work if you want to use the custom UI. Therefore, we will create an add-on based on the script which will run in the background all the time. For this, we need to make a very small change to the code. We need to add additional information that this is an add-on. We need to add the BL-info dictionary. This holds many different information. In this example, the name, the author, the add-on version number and the Blender version, in which I have the add-on developed in. Some of them are optional and there are even more you can use. Just check the online Blender documentation or Google what you can use. When that's done, we save the script as a .py file. The file extension is very important. After saving it, we can already install it as an add-on. So let's head to the user preferences and install it. This might look a bit different to you if you are not on Blender version 4.2. As you can see, even without executing the script, the custom UI is showing. Perfect. Every time you have this rig, this UI will show. If you have any questions regarding the Blender API or some functionality, there's an API overview on a website. It's actually the documentation website Blender offers and there are many different information you can use. For example, how to register classes, how operators work, what kind of different operators exist, and you can actually also search for a feature or what you're looking for, and this documentation really helps you to understand code or functionality even better, and it also helps you to create your own script with a different feature set. But you can also just Google your problem and you will definitely find a solution or some help. For example, I googled Blender Python how to register a class, and there are many different websites that will help you. Either it's YouTube tutorial or a Blender Stack Exchange question, you will find help there. We've reached the end of this tutorial. I hope it will help you to create your own custom UI for your rig. If you have any questions about the tutorial or my channel, feel free to ask in the comments section. If you'd like another tutorial where I dive deeper into a specific topic, please let me know. Thanks for watching.